Everybody, it's Monaco. Our second unit, atomic theory. This is where we're going to really pick up the pace. So I'm going to do my best to not flap my gums all that much and move on quickly. This unit we're going to cover history and models of the atom, atomic and ionic structures and the notation, that's how we draw them, isotopes and average atomic mass, how those are related, how to make some models of atoms like Bohr and Lewis models, and then we're going to deal with some electron configurations and excitation and emission of light from atoms. So this covers all of the atomic structure theory, history, and behavior, this whole unit. Our first lecture is the overarching themes and essential questions, right? We need to know, we're addressing what is an atom? How do we model something we cannot see? We're going to be talking about that in the history section. What makes up an atom? How do we know that these parts exist? Okay. How do all of the parts of an atom behave? Each one of the parts of an atom has a special properties. We're going to get into those, like what protons, neutrons, and electrons do. And what are the different ways we model the atom? Okay, so like Bohr and Lewis diagrams, we're going to learn how to draw, interpret those. And how do we describe all of the observed behavior of atoms and elements using chemical notation? So this whole unit is about understanding the behavior of the atom. Okay, so let's get into our learning objectives. These are our targets. I need you to understand how the model of the atom changed over time, just like any scientific theory or discovery changes over time. I also need you to relate evidence to the models of the atom. What the Rutherford experiment and Thomson's cathode ray experiments meant for the evolution of that model of the atom. Know the names and properties of all three subatomic particles. Be able to find protons, electrons, and neutrons in a neutral atom or an ion given the periodic table. So interpreting the periodic table to find the subatomic particles. Tell the difference between an anion, a cation, and a polyatomic ion. So getting into depth about what ions are. Calculate average atomic mass of an element given the natural abundance of its isotopes. This is the only time this year that you'll need a mathematical formula or approach that isn't presented on our reference tables. Identify and define isotopes by their notations. What an isotope is, how you know that it's an isotope based upon how it's written on paper. Draw diagrams from the Bohr perspective and Lewis perspective of atoms using electron configurations in the periodic table. So again, interpreting the periodic table to make a model of an atom. And understand how electrons behave around an atom. This is where the colored lights and emission and absorption comes into play. So take a gander. There's more assignments this unit. We are not in boot camp anymore. You understand how to do your homework lectures ahead of time to get full credit. You understand how to do Google Forms. You understand how to do a POGIL and what I'm expecting for in laboratory activities. You understand how to do Castle online quizzes and self-studies. The only thing that I've added here is a model project. Okay, check that out. You're going to actually use your CTE, foundational skills, and technology to model an atom of your choosing in the method of your choosing. So I'm excited to see what we get out of that. So that is that for this particular notes.